This video is about Ohm's law. We have that Ohm's law is V is equal to R times I, where V is the voltage measured in volt, R is the resistance measured in ohm, and I is the current measured in ampere, or normally we just said amp. So it is that the voltage is equal to the resistance times the current. The voltage is normally the supply system, where we got a voltage supply. It can be a battery or a generator or whatever we got. Actually, this formula for Ohm's law is not for the supply system. Ohm's law is normally used in the load system, so we can calculate the voltage drop across a resistor if we know the value for the resistance and the value for the current. Or maybe we can find out if we know the voltage drop across a resistor and we know the total current, what it should be in the circuit, then we can calculate the resistance for the circuit or the given component. We have to remember that this formula is normally used just for one component, and if we are going to use it for more than one component, we have to put in the right values for either the current, resistance or the voltage. Now we'll look at a circuit. Here we got a supply system of 12 volts. Actually we got an internal resistance, but we set it to 0 ohm, so we just have a perfect supply system. In the circuit we have a resistance and a lamp, and maybe we know if we got two resistance we can add them together if they are connected in stereo. The resistance for the resistor is 14 ohm and the resistance for the lamp is 10 ohm. So we now can calculate the total resistance for the circuit, because it is just 14 ohm for the resistance added by 10 ohm for the lamp, and we got total resistance of 24 ohm. Now we can calculate the current in the system, because it is the supply voltage of 12 volts divided by total resistance. So we have 12 volt for the supply system divided by 24 ohm, and we got a current of 0.5 amps. Here we got a mobile ammeter, and we just can put it over a wire and it'll give us the indication of the current, and we can see we got 0.50 amp. We got some circuits going around the system, and actually it is an indication of electrons in a circuit. We can see that it runs counterclockwise, and we know that the electrons are going from the negative pole of the supply system to the positive pole out in the circuit. And actually the current goes the other way around, so the current will go clockwise in the system and thereby the other way of the electrons. Now we know that the current in the circuit is 0.5 amp, and if we want to calculate the voltage drop across the resistor of 14 ohm, we just can multiply the 14 ohm by 1.5 amp, and we know that it is 7, but we can just find out by the calculator. Yes, it is 7 volts. So if we're now going to measure the voltage drop across the resistor, we can see that yes, it is 7 volts. It is positive 7 volt because the current goes down this way in the resistor, and the voltage drop, the potential up here is then higher because the voltage potential will be higher if we go in the reverse direction of the current. If we change the probes, we got negative 7 volts. The voltage drop across the lamp must be 10 ohm multiplied by half. It is 5 volts. And we also knew that because the total voltage drop across the components in a system has to be the same as the supply voltage. So we got a supply voltage of 12 volts and voltage drop of 7 volts of the resistor, then the rest of 5 volts must be across the lamp. Let's just say that this lamp is a 6 volt lamp instead, so that we want 6 volt across the lamp. We know that the resistance is 10 ohm, so now we're going to calculate the current for the lamp if there is 6 volts across the lamp. So we got 6 volt across the lamp, and we got a resistance of 10 ohm. It gives us a current of 0.6 amp. Now we know that the current in the system has to be 0.6 amp. And we know that the supply system has 12 volts. So we just can take 12 volts and divide by 0.6. You just have to swap these numbers, so we just press this button and we get 12 volts divided by 0.6 amp. It gives total resistance of 20 ohm. The lamp has a resistance of 10 ohm, and if we got a total resistance of 20 ohm, the resistance up here must be 10 ohm as well. We can change the setting for 10 ohm. And we can see that the current changed to 0.6 amp and the voltage drop across the lamp is 6 volt. You just can control the voltage drop across the resistance is also 6 volt because the resistance are the same. So that was the basic about Ohm's law and how to use the formula. The voltage is equal to the resistance multiplied by the current.